Hello and welcome to this episode of Night Sky News for February 2025 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting all about the possible risk to Earth of the newly discovered near-Earth asteroid 2024 YR4. Plus, we'll be saying goodbye to ESA's Gaia telescope, which has reached the end of its mission. Plus, the link between fast radio bursts and neutron stars. And of course, that discovery of amino acids, the building blocks for life in the material brought back to Earth from the asteroid Bennu. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mentioned will all be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, first up, we got to talk about the planets, because in the past few weeks, everybody has been talking about what's been dubbed the Planet Parade, or planetary alignment in some cases, where 6 planets have been visible at once in the sky. And it's soon to be 7, sort of, as we get into late February. Now, let's just do some quick-fire FAQs on this. Yes, they are all in a line on the sky, i.e. as we see them from our perspective here on Earth. That does not mean they are all in a line in space. They'll line up on the sky because the solar system is flat and we can see them all at once at the minute because they're all piled up on one side of the sun. This isn't that rare that this occurs, that we have all the planets in the sky at the same time. The last time this happened was in 2022. No, you can't see them all with just your naked eye. Uranus and Neptune, you do need binoculars or a telescope to spot them. And it's not something that you can only see on just one night. They've been visible throughout December, January, and into February as well. So if you go outside in mid-February, you will be able to see Mars, Jupiter, Venus, and Saturn with just your naked eye. And in fact, now, tonight, when I've posted this video, is a great time to go outside and look up, because on the 14th of February, Venus reaches the brightest that it gets in the night sky. So if you get a clear night this weekend, make sure to admire just how beautiful it really looks. Now, usually the outer planets of the solar system, like Jupiter and Saturn, they are brightest when they are closest to Earth, and you sort of make a nice line between the sun, the Earth, and one of the outer planets. Then they're like fully lit from the sun. Venus is fully lit from our perspective when it is on the other side of the sun, furthest away from Earth. But when Venus is closest to Earth, we actually can't see it at all because it's lit from the other side by the sun. We can only see the dark side of Venus. It's like, for example, with the moon when it's in its new moon phase. As Venus moves around its orbit, its phase changes like the moon to give us like a crescent Venus or a half Venus. So how bright Venus appears to us in the sky is sort of like a balancing act between how much of Venus we can actually see in terms of its phase, but then also how close it is to Earth in its orbit, because as it gets closer, that phase, the actual amount of Venus that we can see that's lit, actually shrinks. So this actually happens when Venus is in its crescent phase. So if you go outside this weekend and you spot Venus in the sort of west just after sunset, it's fairly high above the horizon. It should be fairly easy to spot because it is the brightest thing in the sky at the moment. Notice how bright it is, and also notice how, to your eye, it doesn't look like a crescent shape. It just blurs to a dot to your eye. But if you break out binoculars or a telescope, you should be able to see the crescent phase of Venus. And of course, once you've found Venus, you can then follow that imaginary line through the sky and spot the other planets as well, Jupiter and Mars. Now, what changes about this planetary parade in the latter half of February is that Mercury starts to come round to this side of the sun, rise higher and higher in the sky above the horizon just after sunset. It reaches the furthest that it can get from the sun in the sky from our perspective here on Earth on the 8th of March. So that's going to be around about the best time to try and spot this, because it is so close to the sun, and therefore it will not rise that high above the horizon after the sun has set and very quickly set itself. Low on the horizon means there tends to be hills, houses, and trees in the way, but also clouds and thicker atmosphere, meaning it's very tricky to spot. The closer you are to the equator, the easier this will be, as it will rise higher for you there. Personally, I've never been able to spot Mercury from the UK. It's just too low on the horizon for me to do that here. But as Mercury rises higher, Saturn is going to sweep around to the other side of the solar system, meaning it's getting closer to the sun on the sky, setting earlier and earlier just after sunset, which means it will pass by Mercury, which is rising higher at the same time, around about the 25th of February, and the two will come very close together again, very low on the horizon. You're going to have incredible conditions to be able to try and spot this or even capture it. I'm talking like nothing on the horizon, super cold, crisp atmosphere. If you do manage to capture it, I will be very impressed. And if you do, you're going to have to send me a picture. Now, as we get into March, the moon will join this planetary parade, which I always like when this happens because it does make it easier for those who, aren't quite sure that what they're looking at is actually the planets and whether they're looking at the right thing. So on the 1st and 2nd of March, the crescent moon is hanging around with Mercury and Venus, and then it moves across the sky until it reaches Jupiter on the 5th, 6th, 7th, when it's about a half moon. And then by the 8th and 9th, it's closer to Mars and getting towards full. Now, it reaches a full moon on the 14th of March when it actually becomes the star of the show, because for those in the Americas, Western Europe and Africa, we're all going to get to see a total lunar eclipse. This is when the moon passes into the center of the Earth's shadow, but because the Earth has an atmosphere, light gets bent through the atmosphere, with red light bending more and still making it to the center of that shadow, turning the moon red. A lot of people like to call this a blood moon, but I think I prefer the name like sunset moon instead, because I like to think of this as like the moon passing through the Earth's sunset shadow to make it turn red. So this is going to happen late night on the Thursday, the 13th of March, into early morning on Friday, the 14th of March. And it depends where you are in the world, what local time you'll see it. I'll pop a link in the description which can show you what the eclipse will look like from your location and at what time it starts and finishes. Here in Europe, we're only going to see part of the eclipse during moon set early in the morning before the sun rises. Whereas in the Americas, you'll get the best view, with the further west you are, meaning you don't have to stay up into the wee hours of the morning to spot this, because you know me, as much as I love stargazing, I also love sleep. So yay for conveniently timed astronomical events. But now it's time to turn our attention to the space news stories of the past month, because there's been some big ones. Like, did you see this one about this new discovery of the asteroid 2024 YR4, which there is a small chance could impact Earth in 2032? Now look, stories like this can be scary, which means media outlets like to play on that fear with attention-grabbing headlines and the ever-present clickbait. So when you see a story like this, how do you know that you can trust it? Well, that's where Ground News comes in, the sponsor that I've been working with for over a year now. With Ground News, I can see straight away that 171 different news outlets covered this story, with 83% of those having a high factuality rating. So with just a few quick glances, I can immediately tell that this story is genuine. But I can also really easily compare different headlines from different news sources. So I can see the Telegraph, they went down the fear-mongering route. They went with highest risk ever, asteroid threat prompts global action. Whereas the Houston Chronicle, they quote some actual numbers there. They went with new asteroid has 1.2% chance of striking Earth in 7 years. And the Daily Mirror gave analogy for the size of the asteroid, right? They went with asteroid the size of London Eye could collide with Earth on one day in 2032. I like to think that this channel and Ground News have some common goals, right? I'm just trying to make space and science more accessible and approachable, and that's what Ground News are trying to do with their data-driven tools that make understanding and staying informed with the news that much easier. It's why I love Ground News, and so many of you have told me that you love it too, which is why I'm so happy that they're continuing to sponsor this channel. The feature I use the most is their blind spot feed, because I find it really interesting to notice which stories get little to no reporting on either side of the political spectrum. So if you head to the link in the video description down below, ground.news/Dr. Becky, or you can scan the QR code up here, you'll get 40% off their Vantage plan with unlimited access to all the features that I've shown here. It comes out to around about $5 a month. Ground News is completely subscription funded, so it's free of ads and therefore any bias that comes with paid advertising. So thanks again to Ground News for sponsoring this video. And now let's come back down to Earth and chat about what's been happening in space news in the past few weeks. All right, first up, we've got to talk about Gaia, the jewel in the crown of the European Space Agency's fleet of telescopes this past decade, which we now sadly have to say goodbye to as it's finished up its science observations. So for some history and context for you, Gaia launched back in December 2013 and made its way out to the stable Lagrange point 2, which is about 1.5 million kilometers from Earth. Yes, that is the same spot that the James Webb Space Telescope is also at, so Gaia and JWST have had some company these past couple of years. While it's there, Gaia has been charting the positions, distances, movements, and brightnesses of almost 1 billion stars in our galaxy, the Milky Way, over the past decade. That's allowed it to produce the largest, most precise map of the Milky Way that we've ever made, showing us our home galaxy like never before. The data we've got from Gaia has helped revise what we think the Milky Way looks like, from how fast the bar in the middle rotates to how much the disk of the Milky Way is actually warped, to the specific structure of the spiral arms of the Milky Way, or the amount of dust in the regions around the solar system out on the edge of the galaxy, to even challenging the best theory of gravity we currently have, Einstein's theory of general relativity, which I've covered before on this channel. Now, as of January 15th, 2025, Gaia officially finished its planned science observations as part of that survey of Milky Way stars. Although the next data release from the end of that survey isn't going to be until next year, 2026, when 500 terabytes of data are set to be released publicly. Now, if you're thinking, why can't we just continue to use it as a telescope now that it's finished like its planned survey? Like it's out there, right? Surely we can just continue pointing it at stuff and it can still be scientifically useful. But unfortunately not. No, it is running out of fuel, the fuel that it needs to point and orient the telescope to actually look at a specific object and actually be useful as a telescope. So that means no more observations, sadly. In the next couple of weeks, though, the team at ESA will be doing loads of tests on the instruments and the tech on board, just to see if we can, learn anything for future space missions and future telescopes we might send up there. Plus, grab at any extra data that people might have questions about in the future when it comes to data calibrations. After all that's done, though, really Gaia will just be given one final push to send it out of its current orbit around that stable Lagrange point 2. That will put it onto an orbit around the sun, well away from Earth. Thankfully, there's nothing to worry about. And there it will stay forevermore. And it will officially be retired on the 27th of March, 2025. Next up, let's chat about the discovery of this near-Earth asteroid that could pose a risk to Earth in 2032. The beautifully named asteroid 2024 YR4 was discovered on the 27th of December 2024 using the Asteroid Terrestrial Impact Last Alert System, or the ATLAS telescope in Chile. And ESA's Planetary Defense Office is now closely monitoring it after initial calculations of the asteroid's orbit gave it a 1.2% or 1 in 83 chance of it impacting with Earth in December 2032. So what does that mean? Well, that percent chance is coming from the fact that we actually don't know the asteroid's orbit very well at all. It's essentially our uncertainty on where it's going to be in 2032. So how this is done is that you spot the asteroid moving across the sky, and one observation gives you, its current position. And then you observe it again, either the next night or a week later or a month later, and you'll have seen it move. And then you've got another data point to work with, and then maybe another week later, and that gives you a third data point. And from there, you have to then extrapolate the orbit to where it's going to be, for the next 100 years is usually the standard for what is done. But data is incredibly noisy, and extrapolating that far into the future means that we do have a very large region of uncertainty of the asteroid could be somewhere in this region, but we're not entirely sure where. Hence the chance of impact with Earth, because Earth would actually cross over with that big uncertain area that we've calculated. Taking more and more observations that are spread apart further in time gives you a much better idea of the asteroid's orbit, because as it moves along its orbit and you study it for longer, you see it move in more of its orbit, so you become more sure of its orbit. But for now, with the observations we have and the calculations we can then do in the extrapolation, it gives it a 1.2% chance of impacting with Earth in December 2032, which puts it at a level 3 on the Torino Impact Hazard Scale that tells us how worried we should be. And if you read the statement for a level 3, you'll see that cause for concern is low here. It's likely that as we take more observations of this asteroid, that percent chance of impact with Earth will change and eventually drop so that we know it is not a risk to Earth. Still, a level 3 puts 2024 YR4 at the top of the risk list for near-Earth asteroids that are potentially hazardous. The only other thing we know about the asteroid is a rough estimate of how big it is, which you can estimate based on how bright it is and how far away we know it is. And by doing that, we get a value that's around about 40 to 100 meters. So it's around about 100 to 300 feet. That range is so big because we don't know what the asteroid's made of, and what it's made of changes how much light it reflects. So you get this quite big range. Either way, that might sound big, but this is nowhere near a planet-killing asteroid like what hit and wiped out the dinosaurs. This is something that if it were to impact with Earth would cause very localized devastation. We're talking about like city-wide destruction, not entire countries or continents. If it were to impact, we don't know exactly where yet, again, because there's so much uncertainty over if it will even impact with Earth, never mind what time of day and therefore where it will impact on the Earth's surface. We need more observations, so that's what people will be doing over the next couple of months and years until we're very certain of its orbit, and hopefully that impact chance drops down to 0 and it drops off any of the Torino impact hazard scale. Now you might see some more fear mongering in the news in the next couple of weeks or months about this, just because like there is a possibility that as we collect more data, that percent chance of impact could go up. Such is the nature of just random noise on data. But as I said, as we get more observations over a longer period of time, that will actually tell us whether we do have anything to worry about or if we can all just sit back and enjoy the fun show when it passes close by in 2032. Next up, let's talk about solving the mystery of fast radio bursts, because this paper by Pastor Marazuela and collaborators caught my eye this month. Having discovered 24 new fast radio bursts using the Westerbork Synthesis Radio Telescope in the Netherlands. Now, fast radio burst is, well, exactly what it says on the tin. It's an incredibly short burst of radio light lasting just milliseconds, but containing more energy than the sun gives out in 3 days. They're very faint by the time they reach us though, because they're so far away. Combine that with the fact that we don't know when they're going to happen, it makes them very difficult to spot. Now, the first of them was discovered back in 2007, and since then we've discovered around about 1,000 of them, and that's mostly thanks to the CHIME telescope in Canada, which can keep an eye on a huge area of the sky at one time. So much that it spotted 500 fast radio bursts in a single year back in 2021. Now, CHIME also spotted the first fast radio burst to come from something in our own galaxy, the Milky Way, back in 2020. And it was traced back to a magnetar, which is a type of dead star known as a neutron star, which is formed when a star dies and collapses in a supernova, crushing all that material down so it's incredibly dense, although not quite dense enough to form a black hole. Magnetars are a specific type of these neutron stars with incredibly strong magnetic fields around them, meaning it can lead to like these big energetic bursts like flares of X-rays or radio bursts in this case. And so one of the leading hypotheses for a long time has been that these fast radio bursts come from neutron stars, and more specifically from magnetars. Now, what Pastor Marazuela and collaborators noticed with the 24 new fast radio bursts, or FRBs, that they've found is that if you look at the polarization of the radio light detected, and you can think of that as kind of like the alignment of the waves of light you're detecting. So light is an electromagnetic wave. It has two components, an electric component and another one at right angles, a magnetic component. And so if light is polarized, it means that all the light is coming with the electromagnetic wave arranged at the same angle. This is how polarized sunglasses work. They only let through light that's coming in at a specific orientation, which is why like it filters some light but not all the light, and it's why you don't sort of like darken the scene with polarized sunglasses. But it's also why, you know, if you wear polarized sunglasses and like look at like a phone screen or even some sort of like sat nav screens in cars, you like tilt your head, you can like make the screen go like fully black because the light from the screen is coming out polarized. Now, light can be linearly polarized, where it's all at the same angle or orientation, or circularly polarized, where it's all rotating around at the same rate and same direction. And so what you can do is you can study the light that you detect from the fast radio burst that you found and say, okay, how much of that light is polarized? And this is what Pastor Marazuela and collaborators have done, finding that on average 43% of the light in each burst was linearly polarized, and on average had a very low percentage of circularly polarized light. Plus, you can also look at the shapes of the bursts that you detect and see that some of them have like double or multiple bursts to them. And in the case of these 24 new fast radio bursts, a third of them had more than one burst in a single event. Now, Pastor Marazuela and collaborators point out that these polarization fractions and the nature of these sort of like double and triple bursts are very similar to what you'd expect from flares from neutron stars and magnetars that we typically see in like X-ray light. So this is yet another paper that seems to have all the signs pointing towards explaining the mystery of fast radio bursts as just bursts of radio light from neutron stars. And finally, let's chat about the big news that NASA has found the ingredients for life in a sample of rock from the asteroid Bennu. Now remember, we have this sample thanks to the OSIRIS-REx mission, which traveled to Bennu, dropped down to the surface, sort of gave it a little slap to jettison material up, and then collected that material into a sample container to bring back to Earth. That sample was successfully returned to Earth in September 2023, and I covered that in a Night Sky News episode at the time, along with a video on the tests that NASA were planning to do on that sample to answer some big questions. And if you look, one of those questions was, are the ingredients for life present on Bennu? Something you can't test with asteroids and meteorites that have, impacted and crash landed on Earth, because as soon as they touch the Earth's surface, they become contaminated with Earth material. So you kind of have to go to an asteroid and bring back material to do this test. And after years of not so patiently waiting, we finally got an answer to this question of whether the ingredients for life are found on asteroids, and it was a big fat yes. So it was this paper by Glavin and collaborators that reported that Bennu was incredibly carbon, nitrogen, and ammonia rich, like way more than we expected given other studies that have been done on asteroids before. Plus, they detected 14 of the 20 amino acids that life on Earth needs to power all the functions of life, essentially power biology, along with all 5 of the nucleases that make up the molecules of DNA and RNA. Not only that, we also had this paper by McCoy and collaborators that reported the detection of a number of salts, including sodium-rich salts, sulfates, chlorides, fluorides, which suggests that at one stage, Bennu could have had this salt-rich fluid covering its surface that has since evaporated off, leaving behind this salty brine on its surface. So why is this a big deal? Because just to be clear, they are not reporting that they have found existence of life itself in this sample of asteroid from Bennu. They've found just the ingredients that we know life on Earth needs to exist, like the building blocks. And the reason people are excited is not because we think that, life could have developed on the surface of Bennu if the ingredients were there, right? We don't think Bennu is hospitable to life. It has no atmosphere. It's, hospitable to life as we know it anyway. The reason people are excited is because this supports the idea that it was impacts of asteroids with the early Earth that brought the ingredients that were needed to get life started here on Earth. The sun will have been much hotter in the early days of the solar system, leading to a lot of evaporation and the Earth being pelted with a lot of high energy radiation. But out on the edge of the solar system, the chemistry that was needed to form these more complex molecules could have occurred, and the asteroids could transport those materials inward. And so with this detection of these amino acids and the ingredients for life on Bennu, that suggests that these molecules were present on asteroids and therefore could be very widespread across the solar system. So if asteroids impacted with early Earth, then they could have also impacted with, say, some of the moons of Jupiter and Saturn that we think might be hospitable to life and that many current and future missions are exploring. Now, like all good science research, these discoveries led to a load more questions as well. So Galvin and collaborators looked at what's known as the chirality of the molecules. So we just talked about light polarization. This is kind of like the molecule equivalent. Essentially, if you have a mirror image of the same molecule, it has different properties. And it's often referred to as whether a molecule has right-handed or left-handed chirality. On Earth, pretty much all the molecules that are used in any biological life process have left-handed chirality. For some reason, we don't know why. But Galvin and collaborators found that the molecules in the Bennu sample were in equal amounts of left and right-handed chirality. So that doesn't help us explain the situation here on Earth that life has evolved to need these left-handed chirality molecules. If anything, it makes explaining that whole situation more complicated. But well, that's science for you. All right, that's it for Night Sky News for this month. As always, if you snap any pictures of the night sky or you come across any space news stories that you want me to cover in a future Night Sky News video, then send them my way over on social media. But until next time, everybody, happy stargazing. So I want to start filming, but I can't because Pip, bless her, is in the closet that I usually dump all my tripods in. Just like asleep in one of the little cubbies. Hi. Oh, stretch. She might push the door open. I guess you better look out for that. For February. There she is. Hi, baby. Coming out from you little sleepies. Where are you going? Oh, you're jumping. Okay, say hi. Yeah. Where 6 planets have been visible at once in the sky. But if you think about looking... Oh, where are you going? You're going under the sofa. Okay. She's been a little bit scared today, I think, because the last people we had around had children, and I think the children scarred her. In a minute, you will notice how dazzlingly... And now, let's chat about what's been happening in space news in the past few months. Uncertainty. How well we don't know. Planet killing asteroid and enjoy the linearly polarized to Bennu. Who's Bennu? This that has evaporated off. Where is this cat?